Hi, today we're going over potential energy, or more specifically, gravitational potential energy. So gravitational potential energy is an energy an object has due to its height. So it's essentially stored energy an object has that can be transformed into other energy as it drops down. Now our formula for gravitational potential energy is PE, standing for potential energy, subscript G for gravitational, and mgy, where m is our mass in kilograms, g is our acceleration due to gravity, meters per second squared, and y is our height. So our first example, how much potential energy is gained when a 1200 kilogram truck is lifted 15 meters with a crane? So we're looking for potential energy. We're given our mass. We're given our change in height. We have our equation. In this case, we don't have to rearrange anything, so we'll just substitute our values in. Calculating it gives us 1.8 times 10 to the 5 joules. We also have what's known as relative potential energy. We use the same formula, but essentially we aren't using our height above ground. We just use the height above another object that something is likely to drop to. So in questions, it'll be useful to select a position at which our potential energy is 0. So we pick our lowest point. So our height at this point might not be 0, but we'll take it to be 0 because that's the lowest point that our object will get. So potential energy at any other point is then measured relative to that 0 position. So for example, a 180 gram book is 2.7 meters above a table that is 1.8 meters high. What is the potential energy relative to the table, and what is the potential energy relative to the ground? So first thing I would do is change my grams into kilograms. So we know 180 grams is 0.18 kilograms. Writing out what we have our mass is 0.18 kilograms. Our y for part 1 is 2.7 meters because we're just 2.7 meters above the table. Our lowest point will be the table. Our gravity is 9.81 meters per second squared, and we're looking for potential energy, which our formula for it is mgy. Substitute in our equation, and we have a potential energy relative to the table of 4.8 joules. For part B, our y is our total height, so that's our height above the table plus the height of the table, so that's 4.5 meters. We're using the same equation, substitute our values in, and we end up with a potential energy of 7.9 joules. Now our work for this section is found on page 165, and there's also a worksheet.